Hi everyone. Now in this session we will revise the time value of money from CFA level 1, and this is your quant subject. Okay, so quant subject first chapter, time value of money. So here we will first start with the compounding and discounting, calculation of the present value and the future value. Then we will see the annuity, in the case the annuity ordinary, annuity due, and then we will also see when there are the uneven cash flows, and we will discuss each and every point in a revision format. So first of all, we have to calculate, or we have to first understand the compounding and discounting factor. So imagine the present value currently is, your investment value is 100, and you want to calculate the future value at time t1 and at time t2. So we want to calculate these two. So for this, we will need simply, for the calculation of the future value at the time t1, we need simply 100 multiplied by compounding factor for time t1, and then for the future value of time t2 is equal to 100 multiplied by compounding factor for time t2, like this. Now how to calculate the compounding factor? So simply, for the calculation of the compounding factor in this particular case, we have to simply take the 1 plus r to the power n right now. Okay, so now 1 plus r to the power n, it will give you the final answer. So here let's assume the r is equal to 10%, and obviously t1 is the 1 year, t2 is the 2 years. So here the answer is 100 multiplied by 1 plus 0.10 100 multiplied by 1 plus 0.10 to the power 1. Okay, so this will give you the answer 110. If you do this calculation for t2, then 1 plus 0.10 to the power 2 is equal to 121. Now instead of writing this like in the full format, you can also write it like 1.10 and then to the power 1, 1.10 to the power 2. This is very good for reducing your calculation time, right? Now this is our compounding factor. So now for the calculation of the compounding factor, we simply know the compounding factor can be calculated as, so 1 plus r to the power n. Now here I am assuming the effective annual rate. Okay, so effective annual rate. Okay, I will also tell you like what if there is a semi-annual compounding, quarterly compounding, right, like that. So this is for the future value. Now what if we want to calculate the present value? To calculate the present value, we have to take the future value multiplied with the discounting factor, and we will get our present value. So here in this particular case, let's assume that the future value for, first we will assume the future value of 100 at the time t1 and then 100 at the time t2. So let's take the future value first, 100 multiplied by, now how to calculate the discounting value? So simply you have to just change this equation. So this 1 plus r to the power n, which is the compounding factor, will get in the left hand side, and it will be 1 divided by 1 plus r to the power n. This will give us the discounting factor. So 1 divided by 1 plus r to the power n, again assuming the effective annual rate. Okay, so 100 multiplied by 1 divided by 1 plus 0.10 to the power 1, whatever is the answer, you have to do the calculation. And then for 2 years, so this is for t1, and present value assuming the future value 100 at time t2. If we do this, then the 100 multiplied by 1 divided by 1 plus r to the power n, this will give us 100 multiplied by 1 divided by 1 plus 0.10 to the power 2. Okay, and you have to solve this and you will get the answer. So let's see how to do this in calculator. You already know this, but just for the revision purpose, simply we have to just start with for this particular part. I will also show you like how to do these two calculations first. So 1.10, simply you don't have to do anything, multiplied by 100, and then for 1.10 square, simply put the square, multiply by 100. If you have to do the calculation for 3 years, then 1.10 y to the power x to the power 3 is equal to 1.33 multiplied by 100, and 133.10 is your future value. If you have to do the calculation here in the case of discounting or the calculation of the present value from the future value, so then we will start with the 1.10 1 by x multiplied by 100, and our answer is 90.90. And here 1.10 square 1 by x multiplied by 100, and this is 82.644. Now here the discounting factor, the answer for this discounting factor is 0.9090 like this, and here the answer for discounting factor for the 2 years is 0.8264. So now see, we got the compounding factor and discounting factor. Now again timeline. So to go from here to here or here to here, we are using formula which is 1 plus r to the power n. If we have to do this in the reverse order, then we are using the formula that is a discounting. We are doing 1 plus r to the power n, 1 divided by 1 plus r to the power n, and this is the discounting factor, and this is the compounding factor, and this is assuming the annual rate. Okay, so this is assuming the annual rate. What if we have semi-annual compounding? And then say quarterly compounding and maybe monthly compounding. For the semi-annual compounding, we have to simply tweak this particular formula. So we will go like, for the compounding, 1 plus r divided by m to the power m multiplied by n. Simple. And this m is your periodicity, okay? And n is number of years. R is obviously your rate, okay? And again, the same is, the m is periodicity. Periodicity means in semi-annual there are 2 periods in 1 year. So we will take 1 plus r divided by 2 multiplied by 2. If we are doing this calculation for just 1 year, then simply put it like this. So multiply by 2. If we have to do the calculation for say 2 years, then 2 multiplied by this 2. First 2 is for the periodicity, second 2 will be for total number of years. If you have to do the calculation for 2 years. So if you have to calculate the future value, assuming the present value is 100, simply multiply 100 with this, or assume 10%, okay? And we can easily do the calculation. Let's see how to do the calculation here in this particular case. Just a second. Yeah, okay. Now, the future value is equal to present value is 100 multiplied by assuming the 10% rate. Okay, so here 10% rate, this is semi-annual and for 1 year. If you do this, you have to simply solve this calculation, and this is 0.10 divided by 2 plus 1 y to the power 2 multiplied with 100, and the answer is 110.25 like this. Okay, this is for T1. Okay, the future value at time T2 is equal to 100 multiplied by 1 plus 0.10 divided by 2 again for the 2 years, 2 periods in 1 year multiplied by 2, and here we have to simply do this. So we already know 0.10 will divided by 2 is 0.05, so simply 1.05 y to the power x4 multiplied by 100, and the answer is 121.55 like that, simple. Then if we have to do the calculation for the discounting, the present value calculation, and we will simply use the present value at time T1, meaning the future value of 100 is at the time T1. So here simply 1 plus 0.10 divided by 2 to the power 2 multiplied by 1 if I have to do the calculation for 1 year. And here I will just show you for the first year. For second year you can do by yourself. So here this is 0.05, 1.05 we already know, because 0.10 divided by 2 will be 0.05 plus 1 will be 1.05 to the power 2, square it 1 by x and multiply it with the 100. Okay, and the answer is 90.7029, like this. That's it. Okay, so this is compounding and discounting and the calculation of the present value and the future value when there are the different compounding frequencies for the semi-annual, for the annual, for the monthly. If you have to do the calculation for the monthly, then the future value for say 2 years, T2 will go like this, multiplied by 1 plus 0.10. Now what is the periodicity? Monthly. So there are 12 months in total, so total 12 periods. 12 multiplied by 1, whatever is the answer, is your future value. So for this calculation, we have to take the 0.10 divided by 12 plus 1, y to the power x 12 multiplied by 100. The answer is 110.471, like this. Okay, and if I have to do the same calculation in case of the discounting, so present value is equal to future value multiplied by discounting factor. Calculation of the discounting factor will go like this, to the power 12 multiplied by 1 for the 1 year, and then you have to do the calculation. So 0.10 divided by 0.10 divided by 12 plus 1, y to the power x 12, 1 by x multiplied by 100. This is 90.52, like this. Okay, so this is the present value and the future value calculation with the compounding factor and the discounting factor. This is very simple and straightforward. Now let's talk about the next discussion. Just a second. Annuities and perpetuity. So first we'll start with the annuity, and here in annuity we have to use the special function in calculator, which is the TVM function, time value of money function. And for this we'll start with the very basic illustration. Assume a bond paying coupon of say 10% with the face value 1000. Remember, the face value is 1000. Okay, and time to maturity is say 3 years, meaning 1 2 3, and here you will get 100 in coupon. Here you will get 100 plus 110. Now the first approach is you can simply discount all these values and simply take the summation, total it, and you will get the present value of cash flows. Okay, so this is the first approach, and this is our bond price. We can do the same calculation using the TVM calculation or the TVM function of the calculator. And here, so first we have to start with the clear TVM, feed 100 in PMT, then 1000 in future value, then yield is required here. So let's take I by Y is equal to say 12%. Now 12 I by Y and 3N. CPT PV, answer is 951.9633. Okay, so this is our present value of all the cash flows. This is one approach. Now what if this yield or say coupons are semi-annual? So if we have the coupon semi-annual, so there are two approaches. We can adjust the periodicity in calculator itself by keeping all the values same, but this requires like a lot of complexity. Okay, so your calculations will get complex simply because you have to change your calculator mode again and again. So instead of doing this, we will go by the simpler approach. And in simpler approach, let's assume this coupon is semi-annual, and again, so coupon rate is 10%, but semi-annual now. So you will get 50 for every 6 months. N is equal to, still we have 3 years, means total 6 periods, 6 semi-annual periods. And we have I by Y currently 12%, means periodically this is 6%. And okay, so this much information is enough for us. So we'll again start with the clear TVM, 50 PMT, 1000 future value, I by Y is 6%, simply feed the 6, and total 6N. CPT PV 950 here the present value or the bonds price is the 950.8267, like this. Very simple. Now, next is the annuity and the perpetuity. Let's first discuss the annuity. Annuity means there are cash flows for a limited number of periods and you have to calculate the present value or future value depending on the scenario. But we have some cash flows, okay? So fixed cash flows. Now, simple, we have first the annuity ordinary and then we have the annuity due. So annuity ordinary means when you consider this particular timeline and this is your time T0, the cash flow will start at least from T1, maybe it can start from T2 or T3, but at least from T1. But when the annuity is due, then the cash flow will start from T0 and this will change your calculations. This you need to remember. Okay, so just a second. Okay, I hope this is visible. Okay, now see, for the annuity due, for the annuity ordinary. So there are two scenarios. First, the cash flow is starting from T1. So we already saw how to do the calculation if the cash flow is starting from T1, but here we will assume, like in annuity, the cash flow is consistent, okay? And there is second scenario where cash flow will start from maybe T2, T3, T4, but not from T1. Okay, so there are two calculations. Now first, the cash flow is starting from T1. So this means if I have to give you the example of say 3 years, so the cash flow will be like 100, 100 and 100 like this. So we can still use the TVM calculator here and we want to calculate say present value. And in this particular case for the calculation of the present value, we have to simply start with the clear TVM, feed 100 in PMT, FV will be equal to 0, I by Y, let's assume 10%, then the period 3 CPT PV and this is 248.685 like this. Okay, so this is the first thing. So the cash flow is starting from T1 itself and you can do the calculation like this. Then the next is cash flow is starting from later than T1. Okay, so this is your T1, this is your T2. Let's assume the cash flow is starting from T3, then T4 and then T5. So here we have 100, 100 and 100. And this is your investment plan which provides you the cash flow after at the end of third year. And then you have to calculate the present value. Obviously, we all know the present value gives us the answer to how much we should pay for this particular cash flow. And the cash flow is for the 3 years. Now what to do in this particular case? So here the approach is, we are calculating present value at this particular point at T3. So T2, we can say the PVT2 and then we will calculate the present value again. Let's assume the I by Y is equal to 12% and rest of the calculation is same. We have this for the total of 5 years, but our TVM calculation will go on for 3 years. So this is the first year, second year, third year. Okay, so first year, second year, third year. So first we will do the calculation for the 3 years. So 100 PMT, 0 FV, 12 I by Y, total 3 periods. So these are 3 periods, CPT, PV, and we have our answer 240.183 and this is our PV at T2. Now we have to calculate the PV, okay? So PV at time T0. So for the PV at time T0, we will simply discount 240, the present value at time T2 to the T0, okay? So here, so 240.183 divided by 1 plus 0.12, 12%. Let me check. I hope we did the right calculation. Yeah, okay. So 12% and this is for the 2 years and we have to calculate this answer. And the answer is 1.12 square 1 by x. 1.12 square 1 by x multiplied by 240.183 Whatever is the answer, 191.4724 is our present value at time t0. That's it. Okay. So we got our present value at time t0 when the cash flow starts from later period, not from t1, maybe from t2, t3, and so on. What if this cash flow is from the starting from the t2? In this particular case, then you have to calculate the present value at time t1 and you will discount it for 1 year. So when we took the value of n is equal to 3, so that gave us a discounting impact of 3 years, and then this 2 gave us the discounting impact of remaining 2 years. So total discounting is going for the 5 years in total. So you can reconcile everything like this. Then next is the future value calculation. So if you want to calculate the future value in the same case, and again we have cash flow like this. Okay, let's take the 3 years. So T1, T2, T3, and here we have 100, 100, 100, and we want to calculate the future value at this particular point. So you don't have to worry about it. The future value, this particular FV function will give you this value. So again, clear TVM, we are taking I by Y is equal to 12%, 3 total N. Then 100 is our PMT, 0 PV, CPT, FV, and the answer is 337.44. What are we doing here? We are simply compounding these values and then we are taking the summation. Okay, simply totaling it. That's it. Okay, so this is the future value calculation when we have the annuity ordinary. Now we can do the calculation for the annuity due. What is the difference between the annuity due? In annuity due, the cash flow, this cash flow is starting from T0 like this. So this is T1 and this is T2. So again, the time period is 3 years only, 1, 2, 3, but cash flow is starting from T0, T1, T2. So we can also say like this. So cash flow is starting from the beginning of period instead of ending of the period. If the cash flow is starting from the end of the period, then the cash flow will be like this, 100, 100, 100. But because this cash flow is starting from the beginning of the period, we have to simply adjust your TVM function. So there are two approaches. First approach is go by the present mode, don't change the calculator's mode and use it like this only. So here, if we do the calculation, assuming the normal mode of the calculator and assuming the T0 cash flow is, just a second. Cash flow is starting from T0, then in that particular case, like here. So what we will do? We will first calculate the present value. Now see. Second clear TVM, we have to start with second clear TVM. Now 100 PMT, don't bother about future value because by default it is 0 only. 3N, 12% I by Y, we are assuming it from the previous calculation only. And let's calculate CPT PV. And the answer is 240.183. But remember, this calculation is giving you the present value at this particular point. Okay, so this 240.183 is for this period T-1, and you have to get it to this level. So for this we can do this calculation. So PV0 is equal to, so 240.183, which is from T-1. So you have to compound it. Okay, so pull it forward. For this 1.12, simply multiply it with the compounding factor. 1.12 multiply by 240.183, and the answer is 269.0049, like this. Now we can also change the calculator's mode. Here, just see how to change the calculator mode. And here we will shift our calculator. So right now the calculator is assuming the cash flow is starting from the end of the period. So whenever you're taking the 3N, N is equal to 3, then cash flow is starting from the end of the period. So T1's end, T2's end, T3's end, and so on. We will tell calculator, no, start from the beginning. Second begin, second set, this will enter into the begin mode. And if your calculator is in the begin mode, then it will show you BGN in here. Okay, so at this particular point. Now we will feed the values. same values. So second, clear TVM, PMT. Rest of the calculation will be done by calculator itself. Okay, you don't have to adjust any other thing. So now here CPT PV, and answer is PV0. Answer is 269.0051. There are like some approximation error, because here what we did the 1.12, that is the multiplication, the compounding part. So for this reason there is slight error, okay, but still fine for our exam purpose. Now this is the annuity due when it is starting from T0, time T0. So again, you have two options. You can change the mode. To change the mode again, and always be very careful if you are changing the mode, always use your calculator in the end mode, and whenever you want to use the begin mode, in that case only you have to shift it to begin mode and again change it to the ordinary mode, the normal mode. Okay. Mode begin, mode end. The PV of 80. Yeah, that's fine. Okay, so we are done with the present value calculation. We can do this calculation and we can also calculate the future value here. Okay, so now how to calculate the future value again? So this is our 3 years cash flow is starting from T0, and we have to calculate the future value. Here, please remember, to make sure your calculations are perfect, always set your calculator in begin mode and then 100 PMT, 3N, 12 I by Y, CPT, FV. Something is wrong here. Okay, so second, clear TVM first. So 100 PMT, 12 I by Y, 3N, 12 I by Y, 3N, CPT, FV. And the answer is 377.932, like this. Okay, now next, when there are uneven cash flows, mainly we use this for the NPV calculation, the project analysis. Okay, so for the uneven cash flows, let's assume the cash flows like this. So uneven cash flow. We also have one particular discussion, the perpetuity. So perpetuity is the simplest calculation. Okay. So now here the assumption, like in the annuity, we know the fixed cash flow, the same cash flow is for the fixed period. Here in perpetuity, this is for the indefinite period. Okay. So for the infinite periods. So here, if you have cash flow is equal to 100 for the indefinite period, and you want to calculate the present value of this investment, then you have to simply divide it by whatever is your I by Y, or simply yield. Okay, so divide it by yield and you will get your answer. 100 divided by 0.12 and you have your answer 833.33, like this. Okay, so this is your perpetuity. So we saw the annuity's present value and the perpetuity's present value. Now let's see and this much is the calculation. In perpetuity, there is no, like, we don't have any complex calculations. Now, in case of the uneven cash flows, we will start with the first one, present value in case of the uneven cash flow, which can be calculated using the NPV function. So, uneven cash flow. So for this, let's assume the cash flow 200, 300 and 400, and we have to calculate the present value at time T0, which can be calculated using the NPV function. In this particular case, we have to use the separate function here. So this NPV function and NPV clear work, NPV second clear work, okay, and cash flow second clear work. Okay, so our cash flows are clear now. Now let's see. So first, for the cash flow CF0, set it as 0, down. 200, enter, down. This is F01 is for the period. So 200 is for only 1 year. So then C02, 300, enter, down, for 1 year again. So then 400, enter, down for 1 year. Okay. Now NPV, we want to use say 12% of rate for the calculation of the present value. So set it as 12%, calculate down, and then you have to compute NPV. So compute NPV. So the answer is 702.44441. Okay, you can take the 442, no problem with that. This is your present value. If you want to calculate the future value, then in this particular case, simply press down the NFV. So NFV at this particular point. So this is 986.88. Okay, so we got the NPV, we got the NFV. So net future value, net present value. So these are the calculations, and then we also have the compounding frequency, discounting frequency, then the impact of the compounding and discounting. Like if your compounding is higher, okay, so that is say instead of annual you have semi-annual, maybe monthly, maybe quarterly, and so on. So as you increase the compounding, the impact of discounting or compounding will increase. Always remember, impact of compounding or discounting will increase always. Okay, if you are, this is when, if we increase frequency of compounding, that is increasing frequency means per annum to maybe 6 months or to maybe 3 months, or maybe monthly, okay, or maybe daily. Okay, in this particular case, whatever you are doing, compounding or discounting, the impact will increase. What I'm saying, the impact will increase. So now for compounding, the present value gets converted into the future value, right? So you are increasing. So for the present value to future value, as you increase the compounding factor, its value will increase. This is what you need to know. Okay, so there are calculations in your book. You can simply check that. The calculations are very easy, but the impact is increasing finally. So this means the final impact, that is present to future value. If you increase the compounding, your future value will increase. It will slightly increase, but it will increase. This is the one thing. Second, if you are calculating future value from the present value, then we are discounting, and the impact of discounting will increase, means there will be higher discounting if you take the higher frequency, higher periodicity. So the discounting will increase, means the value will become lower and lower with the increase in frequency. So discounting's impact is increasing. So what discounting does? Discounting reduces the future value to present value. So the reduction will increase. Okay, so your value, the present value, will be lower and lower as compounding frequency increases. Compounding frequency increases. And when you are taking present to future value, your future value will keep increasing as the compounding frequency increases, like this. Okay, so this is all about the time value of money's revision. There are other miscellaneous concepts which we will cover in the fixed income section, because right now, even if we cover here, it does not make a lot of sense. Okay, so that's all about the time value of money revision. Thank you everyone. Thank you for watching this video. See you in the next video. Bye bye. Take care.